In the next several lectures, I'm going to discuss some very specific periodic trends. So what I'd like for you to do is while this lecture is going on, that you have your periodic table out, whether it's the one in your lab notebook or the one in your reference tables, so you can note those trends. Okay? So all periodic table trends are influenced by two different factors. The first is the energy level. The higher the energy level, the further away from the nucleus you get. Okay, so the further away the valence electrons are, and their distance from the nucleus affects how they are going to interact with other elements and other atoms. The second thing that influences periodic table trends is the charge on the nucleus, and that is to say, the number of protons. So the more charge there is in the nucleus, the stronger the pull is going to be on those electrons. So remember that opposites attract. Positive and negative charges attract one another, okay? And the strength of their attraction is based on two different things. It's based on the amount of charge that there is, so the number of protons in the nucleus. It's also based on how far away the electrons are from that nucleus. So the energy levels play into that role as well. Okay, so just keep in mind that those are the two things that are going to affect every trend that I'm going to discuss in the next few videos. Okay, so energy levels affect the trends within the group, and the nuclear charge will affect the trends that happen across a period. So energy levels affect up and down in the group, and nuclear charge across in the period. So the first trend I'm going to talk about is atomic size. Okay, and this is a trend within the group that we're first going to talk about. So as we go down a group, so this is the first group, the alkali metals, not including hydrogen, but we have hydrogen and then lithium, sodium, potassium, rubidium. As we go down the group, you can see that the atom gets bigger and bigger and bigger for that specific element. The reason is we know that the rows on the periodic table correlate to the energy levels. So the further you go down the periodic table, down within that group, you're adding another energy level and another energy level. So it gets larger as we go down the periodic table. Okay. Now let's just talk for a second about atomic size. Really, atomic size is, how do we measure atomic size? We don't have an atom. So we have to do this experimentally. And essentially what we do is if we have two atoms next to each other of the same element, we measure the distance between their nuclei, and that sort of gives us an idea of their general size. We know that the electrons are sort of in these clouds, these regions of probability, and so that's really difficult to measure, right? So atomic radius, or atomic size, is measured by taking the distance between two nuclei of two bonded atoms. Okay, so as we go down the group, the atoms get bigger and bigger and bigger because the more and more energy levels, more and more electrons. As we go across the period, so from left to right across the period, the size gets smaller and smaller and smaller. So remember, across the period is based on not the number of energy levels, because as we go across sodium, magnesium, aluminum, silicon, if you're looking at your periodic table, they all have the same energy level. So what makes them get smaller? It's not the energy level. Remember, it's the nuclear charge. So the fact that as we go from sodium to magnesium to aluminum, we are adding more and more protons into the nucleus, the strength of the nuclear attraction to those electrons causes them to suck in and get closer and closer to the nucleus because there's more and more positive charge. Okay, so that is the reason why as we go across the periodic table, the atoms get smaller and smaller, even though they have the same energy level. Okay, so the outermost electrons then are pulled closer. So on your periodic table for atomic radius or atomic size, I want you to draw in arrows showing the trend. So across the periods, we have the size generally decreasing as we go to the right, and as we go down a group, the size generally increases.